Okay, in our first video we derived the general solution to the wave equation, and now we are going to derive the D'Alembert's formula. Okay, and for us to derive the D'Alembert's formula, we'll make use of the general solution to the wave equation that we derived previously. Now, if we consider an initial value problem, utt is equals to c squared uxx, and you can note that this particular first equation is the wave equation with an initial position of ux0 is equals to f of x and an initial speed, this initial velocity of ut of x0 is equals to g of x. Now, we derive the general solution to the wave equation to be a function p of x minus ct plus q of x plus ct, where actually p and q are just arbitrary functions. And now we have the solution to the wave equation. U of x t is equals to p of x minus ct plus q of x plus ct. Now, if we take a derivative of first partial derivative of u of xt, we obtain ut of xt to be equal to minus c p prime of x minus ct plus c q prime of x plus ct. And if we replace this in the initial condition and the initial speed, initial position and the initial speed, which are the initial conditions anyway, we get u of x0. We said it is f of x, which we replacing will obtain p of x plus q of x. And ut of x0, now t is 0, which will be g of x is equals to c minus c p prime of x plus c q prime of x, because t is 0. And now we want us to do something here that will help us in deriving this formula. Now, if we take g prime of x to be equal to capital G prime of x to be equal to g of x, here we mean now the g of x, capital G of x will just be the integral of small g of x. Let me write it here. Integral of small g of x is a small g of x dx. So this is what we are going to use. Now g of x will be, now g of x, it means we are integrating small g of x, which means we are obtaining, instead of minus cp prime of x, we are having minus c p of x plus cq of x. Now we now have f of x to be p of x plus q of x, and capital G of x to be minus cp of x plus cq of x. Now we can add both and also subtract both to obtain equations that we are going to use as we continue with our derivation downstream. Okay, so if you add the two equations, we get f of x plus 1 over cg of x to be equal to 2q of x, and if we subtract, we get f of x minus 1 over cg of x to be equal to 2p of x, like p of x minus p of x, we get, it becomes a plus, so we get 2p of x. Now we have q of x to be equal to a half if we divide both sides by 2, we will get q of x to be a half f of x plus 1 over 2c g of x, and p of x will be a half f of x minus 1 over 2c g of x. Now, if we now come to get u of x t, right? Now, we are not now having only x. Now, u of x t will be 1 over 2 f of x minus ct minus 1 over 2 g of x minus ct. And if we go back, you will realize u of x ct is equals to p of x minus ct plus q of x plus ct. And this is what we are replacing here. We are replacing q with the q of x plus ct and p with the p of x minus ct. That's why where we had p of x minus ct, we are having 1 over 2 f of x minus ct plus 1 over 2 g of x minus ct. Since p of x minus ct, we've found it to be 1 over 2 f of x minus 1 over 2 c g of x, and plus q of x minus ct, which gives us the second and the third components of this equation. Now, we can put the like terms together such that we have u of x ct to be a half f of x plus ct plus f of x minus ct, and plus a half 1 over 2c capital G of x plus ct minus g of x minus ct. Now, you remember somewhere here we said g prime of x, we define g prime of x to be g of x, which means g of x will be equal to the integral of capital G of x to be the integral of g of x. Now, at this particular point, now if capital G of x is the integral of small g of s ds, now g of x plus ct minus g of x minus ct will be the integral from x naught to x plus ct of g small g of s ds minus now the integral from x naught, this initial position, up to x minus ct g of s ds. But there's a trick here in that if this is we are subtracting, right, and we are starting from x naught to x minus ct, we can change this subtraction sign to be an addition and invert the limits. Now we will have plus, we'll have a plus here, and it is starting from x minus ct up to, and the upper limit is x naught. So this is a trick we apply. We invert the limits and change this sign to a plus, and now we'll have a capital G of x to be the integral from x minus ct to x plus ct g of s ds. And now we have now found the g of x plus ct minus g of x minus ct, which we can now come and replace it in this particular equation. Now when we replace it there, we now obtain this function over here. U of xt is equals to 1 over 2 f of x plus ct plus f of x minus ct plus 1 over 2 integral from x minus ct to x plus ct of g of s ds, which we define it as the D'Alembert's formula for solving the wave equation, which is an initial value problem given at this particular point. So this is the D'Alembert's formula that we are supposed to derive to solve the wave equation.